Hello there. What I have up on the screen here is part of a Google Earth image that relates to the contours exercise number 9 in your textbook. That's on page 234. I suspect that not everybody has access to Google Earth. And even if you do, you have to load quite a few files. So it's maybe, I'm a little worried that everybody will be able to get to it. So instead, what I'm going to do is walk you through the exercise here and lead you up to the answers, and then you'll answer when I pause there. So we're going to start with question A, again on page 234. Question reads, check and double click the Dinosaur Ridge place mark to fly to where the ridge is cut by Interstate 70. Using the map, what is the contour interval of the map at this zoom level? So if I put the pointer over this, you see this is for A and B, and this is Dinosaur Ridge. So I'm going to double click on that. And you can see the elevations associated with the contour lines, barely. So hopefully you can read them. I'll read them for you. I can barely read them myself. The top one here is 6,600. This next one down is 6,560. Then the next one below that is 6,520. That's the one that wraps around here. The next one down is 6,480. 6,440 we can't see. I think it's behind the marker there. And then this line here is 6,400. 6,400 goes like this and is crossed by the highway. So question A is asking again, what is the contour interval here? I'll read the elevations again, starting from the top of the ridge, 6,600, 6,560, 6,520 for that line there, 6,480, 6,440, which we can't see, then 6,400. B, using the map, what is the relief, difference in elevation, from the place mark location to the bottom of the gap where the interstate passes through the ridge? Interstate 70 passes through the ridge being this part here. Let me see if I can mark it and make it a little bit clearer for you guys to see. The ridge is indicated by the contour lines here. The ridge, and then it stops there. There's a gap, and then the ridge continues here. And there's the highway, obviously. At the bottom of the gap, where the highway crosses it, we see this line 6,400, and then we have another line, lower still, that would be 6,360, considering the contour interval of 40 feet. So if this line here, where at the bottom of the gap, which cuts the ridge, if that line there is 6,360, we're going to compare that to the line, the contour line that the place marker is touching, which you can probably barely see. I'm going to again try to mark that. I would say they are talking about this contour line right there. And that contour line is 6560. So if this is 6560, and this contour line here is 6360. 6360. Then what would the relief be between those 2 points? All you need to do is subtract. Part C. Check and double click the depression place mark to fly to. You guessed it, a depression. Let me find that over here. It says depression on this side. Excuse me. If you hike into a depression, in this case it's actually a mine, from the northeast would be over here, to the west of the stream that flows through Jackson Gulch. You hike upslope, over a rim, and down into the depression, repeating contours when you change gradient direction. If you hike from the southwest into the depression, you do not repeat in contours. Why? Hint, think about contour rules for depressions. So, looking at this again here, if you hike into the depression, which is actually a mine, from the northeast to the west of the stream that flows through Jackson Gulch, there's Jackson Gulch there. That looks like the stream there, that dashed blue line. You hike upslope over a rim and down into the depression, repeating contours when you change gradient direction. Okay. So the contours they are talking about repeating, okay, would be this line here. Highlight that with red. Let me get rid of these arrows, by the way. Sorry, that's probably confusing. Okay. So this line here is the same elevation as this line here. If you hike from the southwest into the depression, from the southwest into the depression, you do not see a repeat in contours. In other words, as you are hiking this way into the depression, you are just descending in elevation the entire way. Going lower and lower and lower. There is no repeat in elevation. That's different than over here, where I marked it in red. This contour line here is going to be 6,400. And this line here is 6,400. As we see, as we trace it around, there it is, 6,400. But as we come from this direction, coming from the southwest and going this way, the contour lines get progressively lower in elevation all the way down to the bottom of the depression. So hence, think about the rules for contours. So that would be coming from your reading in the textbook. Okay, we're going to continue now with the part D, and I'm going to double-click Horsetooth Reservoir path, which is going to take us away from the Denver area towards Fort Collins. All right. Toggle the USGS topo folder on and off and change your view to look at the sedimentary rock layers here. I'm going to try that. Let me move this around here a little bit, see if you guys can see better. See, I lost my orientation thing. Where did we go? There it is. Okay. See if I can. Okay, that's not what I want. Let's try this. Also not what I want. All right. Go. Let's see. Okay. I'm trying to orient this so you guys can see the rock layers better. Use this to spin this guy around. Okay. All right. I'm seeing it. Took me a while myself since I haven't done this. Okay. Now we're talking. So hopefully you guys can see what I'm seeing. Can you see the rock layers? So let me try to illuminate that for you. And draw on here. So the rock layers are these ridges that are jutting out of the ground. Like this. Right-click on the Horsetooth Reservoir path in the Places panel to select Show Elevation Profile. I'll do that now. Right. Contour lines are back. And so what we are seeing here is what the landscape would look like from a side view or cross-section view. Okay. All right, so it says as I, yeah, there we go, great. Okay, so as I put the cursor on the profile, so I'm down in the pinkish part at the bottom, I'm going to run the cursor along, and then on the Google map, you can see those same locations showing up. Okay, so now I'm underwater here. bottom of the reservoir is flat. And then I go up this ridge here, and then there's a little dip, and then another ridge, and then a steep slope going down, and then out like that. What does this suggest about the relative amount and direction of tilt/dip of these sedimentary layers? So let me go back to switch that off. I'm taking away the contour lines by doing that. Move this map out a little bit here. So this is going to require a little bit of thinking on your part. We haven't talked about this too much. The rock layers, I see them myself, but I can't imagine it's going to be quite as obvious to you as it is to me. They are here. This is where the rock layers are jutting out of the earth. Like that. Those same spots would be comparable to this here on the profile. Hopefully you can see my yellow on the profile where the side view is. That would be the same as that. Now, as you may know, sedimentary rock, when it is initially made, the sediment is deposited in horizontal layers. Sedimentary rock always starts off in horizontal layers. But due to tectonic activity, in particular something we call tectonic uplift, sedimentary rock layers can be tilted, and their orientation changed from being horizontal to tilted. So in this case here, could that have happened? Especially considering that we have these ridges jutting out of the ground like that. And considering the slope associated with these ridges, how do you think those sedimentary layers might be oriented? So that's what the question is asking. What does this suggest about the relative amount and direction of tilt/dip of these three sedimentary layers? I illuminated 4, but you can either way, it does not make a difference. So when we're talking about the amount of tilt, use the book again. Okay. That would be 0, that would be flat. That would be 90 degrees. Okay. And then we could be somewhere in between. If the sedimentary layers are tilted to the right on the screen, that would be towards the east. If they're tilted to the left, that would be towards the west. So I encourage you just to give that your best shot. Hopefully my description of that and explanation is clear enough. Okay, so that's it. Hopefully this was helpful. You'll answer those, you'll input those answers into the Canvas assignment that is titled Geotours exercise number 9. All right, good luck.